Hello everyone, and Sir Jules here, and I welcome you back to my YouTube channel. So for today's video, I'll be continuing with our organic chemistry lecture series. And in continuation with our lesson 1.2, let's now proceed with our lesson 1.3, which is the principle in electron configuration. Now, as I've mentioned in my previous topic regarding 1s2, 2s2, 2p6, 3s2, we just don't simply or randomly assign those numbers and letters to give the exact address of a specific atom or an element. It's because it's an identification that we can be able to identify that what specific element is that based on those numbers that we have, as I've discussed previously regarding linear electron configuration. Now, for today's video, I'll be discussing the principles behind it and how and why should we follow this in order to get the exact location of an atom. Now, just for example, if we'll just be randomly assigning those numbers and letters without concepts or principles that we are following, then just like in an analogy, in a delivery package, if we'll be interchanging our addresses, then that could lead to misidentification of or misdelivery, the package or our letter being lost because it was assigned to a different address or an interchange address. Instead of having the street first, then we have the postcode first, or having the city first before the barangay, right? Before the specific. So the same thing can also be applied to our atoms, to our elements, to our electrons. We have a specific set of principles that we have to follow so that we will be guided along the way. All right? So without further ado, let's start our discussion. So the first principle in electron configuration is the Aufbau principle. What does it mean? So this principle states that we should fill the orbitals in order of increasing energy level from lowest to highest. And may I just ask as to what this energy level is represented in our um, electron configuration? That's right. This right here is our energy level. That coefficient, which is represented by the letter N. So it could be N equals to 1, 2, 3, 4. So as you can see here, on our first principle, we should be filling in the energy in increasing energy level order. So as you can see, we have 1, 2, 2, 3, 4, 3, 4, and so on. So we fill in those one first before proceeding with the other. So in analogy, it's just like having building blocks of Legos. We don't start building on the top. It's common sense. We start building on the bottom and then stacking up one by one until we reach the further top, right? So it's from the base up to the top. So that's basically what Aufbau principle is all about. Increasing energy level. And you can't go any other way from that because that's a principle. So just like what I have here, it's an increasing energy level followed by 1, 2, 2, 3, 3, yeah, 4. All right. Now, this second principle is called the Pauli's exclusion principle. So what does this principle mean? So this means that each orbital can hold up to 2 electrons with opposite spins. As I've mentioned earlier in my previous lesson that the S block can house a maximum of 2 electrons with only 1 orbital. I have difficulty in adjusting using this pen. So this is our S block, and the number of electrons it can house at maximum occupancy is 2. That's why thus represented by these 2 electrons. So basically on how we represent electrons with opposite can hold up to 2 electrons with opposite spins. And spin in linear electron configuration is represented by arrows up and down. But since it's actually represented like this in chemistry, it represents only half spins. So like that. It shouldn't be full arrow. It's only half arrow, but since we don't have any image here on Microsoft PowerPoint that can show this half spin, so I just use that one. So as you can see, each orbital, this is the orbital. The orbital for the S block, it can only hold a maximum of 2 electrons inside it. So that's 1, 2, and it should be on the opposite side. So we can't have it having the same spin, such as having like that and like that. No, that's just incorrect. This is the correct one. Should have it in opposite directions. And then the 2s2, since it's still in the S block, it only have one orbital with maximum of 2 electrons. Now, in a quantum state, if you'll take a closer look of an electron, it spins. It's hard to give you an imagination about it, but you can search other videos about how it looks like on a quantum level. But basically, it would more like this one, on opposite direction, opposite spins. But since it spins harmoniously with one another, it should be in opposite, just like the yin and yang. Okay, so that's our second principle. We only have 3 principles in linear electron configuration. Now the third one will be Hans rule. So to simplify what this is all about, as you can see earlier, that in our Hans rule, I'm sorry about that. Basically, Hans rule tells us about that. Just for example, let's have, because the S block only have one orbital, one square only, but for the P block, it can have 3 orbitals, as I have discussed in my previous video, and then each block can only have a maximum of 2 electrons of opposite spins. Now, this basically tells us Hans rule that, let's just say, this should be P5. Let's have it, P5. In occupying these orbitals, we have to place them or fill them one by one first. So that's 1, 2, 3. And then before we go back to the rest of the orbitals or pairing them, we should fill all the ones first before we side them one by one. That's 4 and 5. So that's for the P5. As you can see, I filled out all of these orbitals first before giving them the pair. So similarly, on what the picture that I have here, just like imagine you are boarding a bus on your way to school, and then when you arrive, you're the first one to sit on the bus. So of course, you'll be sitting on an empty seat. Now another kid rides the bus. So of course, he will sit in an unoccupied seat until all of these seats individually are filled out. Then only then the next person who will be boarding the bus will sit beside you or sit with another person, because there are no more unoccupied seats left. So they now start pairing. So basically, that's the concept behind Hans rule. You start to fill out all the orbitals first within a specific block before you start pairing them with their opposite spin electron. Alright? So basically, that's it. Those are the 3 principles of linear electron configuration. First, we have the off-bow, which states that it should be done on increasing energy level trends. So from 1, 2, 3, and 4. It can't go 1, 4, 3, 2, 1. No, it should be 1 first, second is 2, then 3, and 4, and so on. So the farther it is from the nucleus, the bigger is its energy level. The second principle is the Pauli's exclusion principle. as I've shown here on our example, two electrons within the same orbital can't have the same spin. It should be in opposite directions, which is represented by half arrow. So it's one up and then the other is down. So that's it. And the Hund's rule states that we should occupy all the empty seats first before we now start to sit beside another electron. All right. So I hope you guys learned something from this video regarding the principles of electron configuration, and I'll see you in the next one. All right. Thank you. Bye-bye.